the trapezium rule for calculating the estimated area under a curve. The formula for the area of a trapezium where these two sides are parallel to each other. Example 1, we have the curve y is equal to x squared plus 4, and we want to estimate the area between x equals 2 and x equals 6. So we could use a single trapezium like this, where these are the parallel sides and the length of each side here is just the y coordinate on the curve at this point and this point. So when x equals 2, 2 squared plus 4 gives us 8. When x equals 6, 6 squared plus 4 gives us 40. And then we need the length along here, which is 4 units. We put that into the trapezium rule and simplify. So the estimated area under the curve is 96 square units. So is the estimate an underestimate or an overestimate? And we can see that the top of the trapezium is above the curve, so there's this additional area that we did not want, so we are overestimating. We can improve by using more trapeziums. So in this example we're using 2 trapeziums, or 2 strips as it's also referred to. So I've got the area for this trapezium here and the area for this one here, and again the vertical lengths here are given by the y coordinates at these points. So we just use the equation of the curve to work out the y coordinates here. So for example, when x equals 4, 4 squared, 16 plus 4 is 20. So the height of this line here, or the length of that, is 20. Okay, so we have all this. We eventually end up with a formula to work out the area. So to build up to that formula, we can see that these two parts are the same in our working out. So if I factorize out the half times 2, then we're left with the 8 plus 20 plus 20 plus 40, and there's 2 of these 20s. That 20 there is common to both. So 2 times 20. So all I'm doing is I'm simplifying this to this, and eventually you'll see this in the formula that we use. So the area is approximately 88 squared units. This is the formula from the formula book. So we've got half times h here, then we've got some brackets, and then y0 plus yn are these values, and then we've got plus 2 times the sum of some other terms there, which is this part. It's a very easy formula to use. Most of the time you're not even going to refer to the formula, you just write down you're working out like this and get your answer, the estimate. You don't need to refer to this every time. But in terms of the sketch, the very first value is y0, the very last one is called yn, and then any in between are like y1, y2, y3 and so on. And here's the full formula from the formula book, and the h there is b minus a, so that's b, that's a, so it'll be 6 minus 2 divided by n. N is the number of trapezia that we're using 2 in this case. So h would be, if we work it out, 6 minus 2 divided by 2 trapezia, so 4 divided by 2, h is equal to 2. So this value is 2, this one here. So improving our estimate further, we're using 4 strips this time. So the width of each one, that width, which is h in the formula, okay, so this is h, is equal to 6 minus 2 divided by the number of trapezia. We've got 4 of them, so h is 1. So we're going in steps of 1, along the x-axis. So now we know these x-coordinates. We need these x-coordinates to put into here to work out the y values at these points. Now typically we don't work with a sketch. What we do is we create a table of x values with their corresponding y values, and then we just put everything into that straightforward, easy to use formula. So here's my table, and a question may be given in terms of integration. They may say estimate, and then if you see this afterwards, it's not telling you to do the actual integration. Integration will give you the exact area. If the word estimate or approximate is used somewhere, you have to use a numerical method, which is the Trapezium Rule in this case. Okay, so my x values start from 2. They go up in ones all the way up to 6, like so. And then using the equation of the curve, I've got the y coordinates. The estimated area from the Trapezium Rule is 86. And the way that works, you've got a half times h, and h was 1. Then you've got the first value plus the last value. These are the heights of the vertical lines in the diagram. So we had y equals 8 and y equals 40. Here they go. And then it's plus 2 times. Then you need more brackets here. And then you add up any other y value that you've not used so far. So they all go in here. And again, make sure you use the right number of brackets in this. It's a common error to not use brackets correctly and then get the wrong answer. Example 2. So again, we see the use of the word estimate. So we're not actually going to integrate anything, and we're using 4 trapeziums or 4 trapezia or 4 strips, refer to that however you like, and we need to work out h, and h was 2 minus 0 divided by 4. So it's a half, or 0.5. So we have a table. We need to start from x equals 0 and end on x equals 2, but we need to go up in a step size of a half, like so. And then the y values. Some of the y values we can simplify straight away. We know what they are. Anything to the power of 0 is 1, so yeah, we can put 1 there. Anything to the power of 1 is itself. A half squared will give us a quarter. Now a half to the power of a half, or half to the power of 1.5, they will give you long decimal values. So we don't want to be writing those here. It's going to make them working out really messy, so leave them in their exact forms for the time being. We can simplify right at the end. Okay, so the basic formula. So we have a half times h. Our h value was 0.5, so that's that part done. And then you have the first y value, the last y value, you add them together. Remember to use the brackets there, so you've opened brackets for the first time. So we've just done this part, and then plus 2 times, and then open brackets again. Now you're adding every other y value that you've not used so far. So that's this one, and this one. You add them together, y1 plus y2 and so on. Okay, so I've done that here, and I've put in the exact y values at this point, and then I'm closing brackets 2 times at the end, here and here. Okay, if you put that into your calculator, and then there's usually an indication as to the number of decimal places or significant figures they want you to give the final answer to. So I've used 3 decimal places in this one. Okay, so if your trapezia are below your curve, you get underestimates, and if your trapezia are above your curve, you get overestimates. For practice, try these questions.